och välkomna. Under cirka 10 minuter ska ni få följa med mig, Marie och min kollega Per. Ni kommer få se aldrig tidigare visade utrymmen och ni kommer få höra historier som ni inte har hört förut och inte visste fanns. Häng med!
Grimeton radiostation stod färdig 1924 och var då en del av ett globalt nätverk av radiostationer av samma slag. Långvågssändarna här i Grimeton de användes för att sända trådlösa meddelanden, så kallade telegram, från Sverige till USA och närmare bestämt New York. Att vi kallar det långvågssändare, ja det är för att de radiovågor de alstrar är väldigt långa, närmare 18 kilometer. Vi ska nu gå in och beskåda det här stora maskineriet som stationen byggdes för. Det ni ser här inne i sändarsalen, det är de stora maskiner som användes för att sända meddelanden med nära nog ljusets hastighet till New York. Grimeton användes bara för att sända information, inte för att ta emot, utan det gjorde man uppe i Kungsbacka. Grimeton var den optimala platsen för en radiostation av det här slaget, för med sin kustnära placering så kunde man sända ut sina radiosignaler utan risk för att de skulle försvagas av eventuella landmassor på vägen över Atlanten. Ett telegram kostade nästan 7 kronor på 1920-talet, vilket var en stor kostnad då och motsvarade ungefär en dagslön för en vanlig arbetare. Behovet av att kommunicera mellan kontinenterna hade länge funnits och dittills tillgodosetts med telegrafkablar som var nedlagda på havets botten, bland annat Atlantkabeln som länkade samman Europa och Amerika. Under första världskriget blev kablarna mål för krigshandlingar, något som resulterade i en strävan efter säkrare och effektivare kommunikationsvägar. Systemen för trådlös kommunikation växte fram.
Innan vi kan starta sändaren behöver vi slå till dessa knivar som finns i det så kallade transformatorrummet för att få kontakt med transformatorhuset cirka 100 meter bort härifrån. Ursprungligen fick sändaren sin elektricitet från vattenkraftverket Ingredsfors lite utanför Falkenberg. Så, nu är det bara att starta sändaren. Eller bara förresten, förutsatt att inga problem uppstår. Sändaren görs körklar på cirka 15 minuter och till detta behövs 2 sändarvakter. Startar du sändaren, tack! När sändaren var igång fick man ropa till varandra för att kunna kommunicera. Den vanligaste arbetsskadan när det begav sig var just hörselskador. Sändarvakterna tilläts inte att använda något som helst hörselskydd, då man var tvungen att urskilja missljud i maskineriet. Men idag använder vi hörselskydd.
Radiostationen i Grimeton har ett omfattande stationsarkiv som sträcker sig ända tillbaka till 1920-talet. Bland materialet finns bland annat ritningar över det stora långvågssystemet som placerades här och som hade utvecklats av uppfinnaren och ingenjören Alexanderson. Alexanderson var svensk-amerikan och tilldelades under sina verksamma år 344 patent, bland annat det för långvågssändaren som användes i Grimeton. Det som var speciellt med denna sändare var att den var högeffektiv och kunde sända på en särskild frekvens, vilket också gjorde att man kunde tilldela stationen sin egen sändarkanal och en mottagare visste därigenom med säkerhet vem det var som sände. Hans uppfinning gjorde det möjligt att ännu snabbare och ännu säkrare sända trådlösa meddelanden över långa avstånd, något som vi idag tar för givet. Alexanderson är med andra ord ett namn att lägga på minnet och han i hög grad har bidragit till hur vi kommunicerar idag.
Vem var det som arbetade på radiostationen? Under bygget samlades många lokalbor som behövde en extra inkomst och arbetet leddes av ingenjör Norén från Telegrafstyrelsen. Han hade fått till sig av den amerikanska leverantören att bygget av en stor radiostation minsann inte är någon barnlek. Därför var det bra att Norén hade erfarenheter av liknande byggen sedan tidigare. Han var anställd av Telegrafstyrelsen i Stockholm och reste ner till Grimeton för att förhandla med bönderna kring införskaffandet av marken. Den ena efter den andra ville vara säker på att varken ta för lågt eller för högt pris gentemot sin granne. Förhandlingar som krävde mycket tålamod och mycket konjak till kaffet. Bygget påbörjades 1922 och stod alltså färdigt endast 2 år efter, trots en omfattande järnstrejk med tillhörande förseningar.
På stationen fanns en mängd olika yrkesgrupper. Ingenjörer och maskinvakter, mastmålare och kontorister för att nämna några. Maskinvakterna de bemannade stationen i 3 skift, det vill säga stationen var i bruk dygnet runt. Under nattpasset ingick att med denna behändiga dammsugare se över golvytorna och snygga till inför den kommande arbetsdagen. För att se till att detta arbete gjordes ordentligt brukade en av ingenjörerna gömma apelsinkärnor i skrymslen och vrår. Och dessa borta när han kom dagen efter så visste han att arbetarna hade gjort ett ordentligt jobb. Dock lärde sig dessa ganska snabbt var han brukade gömma kärnorna och kunde därigenom bespara sig en hel del besvär. Förutom radiostationen och de 6 antenntornen så byggde man också ett antal arbetarbostäder. Detta kommer att bli den så kallade radiobyn där vi befinner oss nu ungefär 400 meter från själva radiostationen.
I radiobyn bosatte sig bland annat stationschefen och ingenjörerna. På kontoret där jobbade fru Bengtsson med all administration och varje fredag radade arbetarna upp sig på led med mössan i hand för att ta emot sin lön. Fru Bengtsson var den enda kvinnliga anställda på radiostationen under många år.
Till skillnad från många liknande anläggningar så kom Grimeton radiostation att bevaras. Och det berodde på att man här dels placerade in nya sändare i stationsbyggnaden och ut på området uppförde man nya antenner. Och än idag är Grimeton radiostation en aktiv anläggning för radiokommunikation. Dels har vi radioamatörer här på området som kommunicerar med likasinnade runt om i världen. Och vissa av antennerna här ute de hyrs ut för att kunna tillhandahålla kommunikation inom bland annat flyg och sjöfart. Genom detta så fyller vi en viktig samhällsfunktion. Detta genererar också intäkter som kan gå till bevarandet av det gamla maskineriet. Och på så sätt bidrar till att levandegöra kulturarvet.
Nu vet du varför just den här platsen är så speciell och ett världsarv sedan 2004. Det är UNESCO, FNs organ för vetenskap, utbildning och kultur, som utser världsarven på världsarvslistan. Den här platsen är helt unik och finns ingen annanstans i världen. Välkommen att besöka oss.
Okay, so welcome everybody, all visitors here at Grimeton radio station today, this beautiful Sunday, and of course all viewers all over the world. Most welcome to Grimeton radio station. I am Fredrik Wiklund and I am the chairman of the Alexander Association. We are volunteers working on this fantastic, unique equipment from 1924 to keep it in running condition. So we will be starting up this transmitter in a while. But before that, I will take you on a quick tour to get you an idea of what we're going to be running today. So follow me, please. Come on. Hello. So this is the heart of the transmitter, the Alexanderson alternator, consisting of three major parts. A drive motor, 500 horsepower. It's wound two-phase, which is very rare, but that was the common power supply in the US at the time for the development of this equipment. 500 horsepower, 2,300 volts, two-phase. It's connected to a gearbox that will step up the speed with approximately 3. So when the motor is making 1 turn, the alternator is making 3 turns. The alternator consists of a solid metal disc about 1.6 meter in diameter. It has 488 cutouts in the periphery. Around the disc are 64 couples of magnets that can pick up variation in the magnetic flux. When the disc is rotating at its optimal speed, which is 35.2 turns per second, and if we multiply that with 488, we get to 17,200, 17.2 kilohertz. That is our transmission frequency. In order to maintain that frequency, we have to make sure that the drive keeps a very constant speed. To do that, we can adjust the voltage, adjust the rotor. The rotor is open and wound three-phase. You can see that there are 3 slip rings on the rotor. They are connected to a liquid resistor, and in the liquid resistor we can more or less steplessly adjust the resistance of the rotor and thereby adjusting the torque of the motor. But to control the voltage, we use an invention from Ernst Alexanderson called a transductor, and I will show you how it looks like. The two-phase motor has 4 leads. Each lead is going through one of those transductors. In the transductors, we can vary the voltage between about 1300 to 2300 volt by changing the inductance. So we have a very good way to control the voltage here. If you turn around the camera, you will see that there are another 2 transductors used to convert two-phase back to three-phase. Because we have several motors for pumps, for fans, for rectifiers that requires three-phase. So here we are converting 2300 volt two-phase back to 440 volt three-phase. To control the transductors, we use 2 rectifiers. One is used and one is a backup. Here we can produce 500 volt DC. And by adding 500 volt DC to the transductors, we can vary the inductance. Here is another set of rectifiers producing 125 and 250 volt. 250 volt is used to magnetize the alternator. We also use 250 volt to key the transmitter to create Morse code. More about that later. Here we have a set of cooling fans. One is in operation. We will be running number 2 today. It creates a heavy airflow through this manifold down to relays and contactors to cool them, to protect the surfaces of the contactors not to get damaged. So to key SAQ, you have to operate this relay. This relay is then maneuvering either that one or that relay. Today we are running this circuit here with amplification relays, and then we have a set of really large contactors here used to control the speed of the drive motor. So now we will go down to the magnetic amplifier where the Morse code is created. So follow me. And here is the magnetic amplifier. This amplifier is connected directly to the alternator. Each one of the 64 magnets produces 100 volt, 30 amps. And you can see that there are a set of leads coming up here. We have 16 behind this. And on the left, behind, is another 16 and yet another 16 here. So totally 64 leads, producing 100 volt and several thousand amps, going up to the 2 cylindrical amplifiers at the top. In the amplifiers, the 100 volt will be transformed to 2000 volt, and they are then connected to the antenna by one of the 2 copper tubes up the ceiling. The second tube is a common ground of the machine and the antenna. So how do we do the machine? Well, first of all, the antenna is a resonance circuit. It has the same resonance frequency as the transmitter. When the Morse key is up, we have 2 variable inductances here. They will tune the antenna to the wrong frequency. When I push down the Morse key, we can change the inductance here, and the antenna will be resonant with the alternator. Secondly, up in the amplifiers, we can prevent or we can minimize the amplification by a third DC coil, that when the key is 0 or very low, there is a leak. If you are have a really sensitive receiver in Europe, you can detect that leak signal. When the Morse key, the DC is removed and we have so 2 key SAQ. Over to the left is a large antenna to match exactly the alternator frequency. So over to the control panel. Here at the control panel, we have the switch for the main power. We have the switch to start the main drive motor. We have the switches for the rectifiers, 500 volt, 250, 125 volt. here in the center, we have a system called the automatic speed control. I will talk about that a little bit later. And over to the right, we have a set of instruments to tell us what is going on. We can read the voltage, the speed of the motor, the automatic speed control, the power out to the antenna. And then we have push buttons and levers where we can engage, we can adjust water level in liquid resistors, etc. We will go through that more in detail when we start up the transmitter. So by that, it's time to start the transmitter. We have made some preparations to make sure that all the machinery has enough oil. We have not yet, though, connected ourselves to the power grid. We have a separate transformer building where we hook up the transmitter to the 50 kilovolt power supply. Transformer will convert the 50 kilovolt to 2300 volt two-phase. I can do that remotely from within here, the transmitter hall, but I will ask my colleague Anders to go down to the door and make sure that one is out there. Okay, so now we have connected to the 50 kilovolt system, and we can go down. And I will ask my operator, Anders, to stay here at the emergency switch. So there is 0 voltage release that I turn on the main power, and now you can immediately hear that we have an alarm signal, and I can temporarily close that. The alarm signal is telling us that we don't have water pressure, we don't have oil pressure. This machine is water cooled, and the bearing, the alternator, water cooling system. So the cooling water system consists of a centrifugal pump. Outside we have 2 underground water tanks where the water is pulled to the pump, and then the pump will distribute the cooling water to a set of liquid resistors. We have 3 of them, row here, and then further down to the alternator, and then further down to the magnetic amplifier, and then the cooling water goes back again. Anders will begin to bleed the pump by opening up a bleed valve and turning on the water supply. And first we can hear bubbles are coming out to get water, and then after some time we get just clean water. And then Anders will go and start the motor with the switch. And it's a Y delta starter, and now the motor is running, and we can see some water is leaking there at the shafts, but that's okay after 99 years, so we can accept that. And now Anders will start open up the circulation valve so that the pump can start to circulate the water to the entire system. And we can also see up here on the wall that we get about 2 bar or 30 psi water pressure in the cooling system, which is fine. Let's thing that up. So the cooling system is now in operation. We move to liquid resistor. This is a very important component. The tank in the middle is always connected to the rotor. You remember the 3 slip rings to the rotor. And by circulating water and adjusting the level by a motorized gate, we can adjust the water level. And by increasing the water level, we can get more and more tubes, metal tubes, in contact with the water. And by that, decreasing the resistance. When we push down the Morse key, we need to give the motor an extra boost. Then this second resistor is connected in parallel to the first. 2 parallel resistors will get a lower resistance so that the motor will get an extra boost of torque. They contain water and sodium to get the correct conductivity. And the water will vaporize now and then, but this one looks good. Let's see the other one. I think we need to top up a little bit, Anders. It's a little bit hard to see. The level should be about at 400. Yeah. Good. Perfect. Next step would be to turn on the circulation in the start and control resistor here. The third resistor is a backup. It comes from machine 1. We used to have 2 machines here. Moved in 1960. They kept 1 liquid resistor here as a backup. Now we will start the circulation. And we hope we can see that on the camera. There we go. You can now see the circulation. The water is starting to circulate inside. It's filling up, it's overflowing. And Anders is using gloves at 440 volts there, the fingers. All right, let's move on to the next step. Turn on the alarm clock again. Yet another alarm. We have no oil pressure. So Anders will turn on an auxiliary oil pump that will provide oil pressure to the bearings in the alternator during the startup. And now we are ready to start up the main motor. And Anders is walking down to the emergency stop. And now we can see that the motor is starting to rotate. I am an eye on the amp meter here. you can see that right now we have about 150 amps. And over on the voltmeter, we can see that the voltage is 1,300 volts. So then you can calculate the power. It's quite a lot of energy going into that motor right now. But as the speed increases, the amperage will also go down. And we can already see now that we are at 130. We want to wait until we get to 75 amps, until we move on with the other steps. In a while, we will get an alarm for high oil pressure, because the alternator has a built-in oil pump. But in the beginning, in the startup, it needs an auxiliary oil pump to provide enough oil pressure. And as the speed is building up, the pressure will get too high and we will get an alarm. We are at 325 RPM. We to 711.3. That's the holy number in Grimeton, 711.3. Never forget that. And the transmitter will transmit at 17.2 kilohertz. And that was the alarm. Has turned off. And we can move on to the next step to turn on the 500 volt rectifier, the 125, 250 volt rectifier. Excitation current, and turning on the excitation or excitation volt. Immediately increase the voltage by 1,000 volts. Now 2,300 volts, and you can hear the alternator. Now Anders is operating the starter system to increase the water level, to lower the resistance in the rotor, to give the motor more torque. At the same time, he is also running the sluice gate in the control meter to see where we are. A little bit more. And then very soon, we are still not in the correct. You can see the frequency counter up on the top is starting to react. And we can also see that the gauge here from the automatic control is starting to work. Tycker du är bra där? Den är kanon. Ska vi lägga till fläktarna? Det gör vi. So before we can continue now, Anders will go down and start up one of the cooling fans. the automatic speed control is actually a received feedback signal. And it has its own resonance circuit. And when they match, it can adjust the voltage, maintaining a very correct speed. But it needs some help to get there. And we have to adjust the voltage to around 2000 volts. And that has to be the case both at key up and key down. So now we will begin that process to tune. We're connected to the antenna though. That will be the next step. Now, audience here, if you lift off your ear protectors a little bit, you can hear that the noise here is really loud. It's very loud to work in here now. So, and now we will connect to the to the high frequency amplifier, and there we are connected. And now Anders can push the key. To do. Den är bra. Kan nog köra den, va? Det är inte mycket. Ska vi köra lite remsa? We'll switch over to the recorder, the hole punch strip recorder. Det är telefonnyckeln där. Ja, okej. So now we are sending a very short message to the world, consisting of a set of Morse code characters. We are sending the character V, as in Victor. That means hello or hi. And then we are sending the characters DE, which means from in French, and our call sign, which is SAQ. So VVD, SAQ, over and over again. So listeners out there can hear that it's us transmitting. So we will take a short walk and show you the antenna. Den är mutad. Den är mutad. Så. Kom på. Hör du mig? Yep. Ja. All right. So we will take a short walk to look at the antenna. Here we can see a cooling pond used to cool the transmitter in hot summer days. Today it's more for show, but we still run it. And then you can see the 6 towers. Even though there are 6 towers, they all work green. The 6 towers work together, and you can see the wires going from the building and then up to the top. They are used to distribute the antenna signal to each tower. And it's 2.2 kilometers. It's actually not Grimeton over there. It's a okay, so go back in again.
För mycket folk och för dålig kommunikation.
Okay, so come with me. And we have 17,200 hertz spot on. The operator has done a good job. Ja, gör det. So now Anders, he will make some fine tuning by using the manual Morse key and trying to get as much current to the antenna as possible. So we have 65 amps on this. What do you think? Somewhat 65 amps. That is good. Here in the transmitter hall, we also have a laptop with with a receiver in Twente, Holland. So we know that the signal at least is getting to the Netherlands. It's a little bit hard to see, but you can see that there is a line here where SAQ is received. In about 3 minutes, we will switch over to our telegraphist, Kai Sundberg, who will transmit a message to the world. For all the visitors here, you can get the paper copy here. We will also show the message on the screen as we are transmitting it. Du måste gå med kameramannen vid varje ögonblick, hela tiden. Fick du byta? Vad hände? Ja, den ville inte. Han är här, ja. Två. Excuse me. Excuse me. Excuse me. Funkar det? Jag vet inte. Ja, du menar där? Han har växlat allting så här. Helt galet. Jag vill ha den mutad. Very good. Thank you very much, Kai. That was the message to the world. So this time we are commemorating that it was exactly 100 years ago that this machine arrived to the site and was being assembled by a team from General Electric. And at the same time, the rest of the site was expanding and was being erected at a rapid pace. So June, July 1923, it all happened. So 100 years ago. So now we are getting to the point where it's time for us to switch off the transmitter. So we will begin by doing that over here. So the first thing Anders will do is to remove the field current to the alternator and to the 500 volt rectifier. And by that we can stop the main motor here by pulling that knob. And the liquid resistors will be run to the bottom position. Very good. And we will turn off the rectifiers, the 500 volt rectifier and the 125-250 rectifier. And Anders will then go and turn off the fan. Jag går det hållet om du vill. And we will soon get an alarm again. And now the alarm is telling us that the built-in oil pump cannot provide sufficient oil pressure, so I would have to switch on the auxiliary oil pump. It takes about 9 minutes for the alternator to come to a complete stop after we have cut the power. Because of the mass, the disc inside the alternator weighs 1,500 kilos. So it takes 9 minutes for it to come to a stop. So by that, it's time for us to say goodbye from Grimeton. Before we do that, I would like to say a few words to all the donors, people who have donated money to us through this year. We have been receiving very generous donations, which has made it possible for us to continue the work to keep this machine in operational condition, and also to get equipment to transmit live to the world like this. So thank you very much, all donors. I would also like to say that we very much would like to get new members. If you visit our website, alexander.n.se, you can sign up to become a member of our association. It costs 125 Swedish kronor, about 12 euro per year. And your membership is very appreciated. So by that, I would say thank you very much for watching, and thank you everyone here in the transmitter hall for your attendance. We will be back in the ether in a couple of hours, about 13:10 local time. That is 11:10 UTC. So see you then again. So bye-bye from Grimeton. Thank you very much.